Welcome, fellow engineers, to a journey into the future of application monitoring. In today's cloud-native landscape, our Java applications are often distributed across complex microservices architectures. While incredibly powerful, this complexity creates a massive challenge. How do you keep track of performance, identify bottlenecks, and quickly resolve issues before your users even notice? Traditional monitoring tools often fall short, drowning us in alerts and manual data correlation. But what if artificial intelligence could lend a hand, watching over your Java apps 24/7, learning their normal behavior, and pinpointing anomalies with precision? That's exactly what AI-powered observability brings to the table, and in this video, we'll dive deep into how you can integrate these intelligent systems, like Dynatrace or new Relic, with your Java services for smart anomaly detection. Get ready to transform your monitoring strategy. Why embrace AI for monitoring your Java applications? The answer lies in the sheer scale and dynamic nature of modern cloud environments. Firstly, automated anomaly detection. Imagine trying to spot a subtle performance degradation across hundreds of microservices. AI algorithms, unlike human operators, can continuously analyze vast streams of metrics, traces, and logs. They learn the normal operational baseline for your application and immediately flag any deviation, no matter how minor, often predicting issues before they impact users. Secondly, faster root cause analysis. When something goes wrong, time is money. AI can correlate disparate pieces of telemetry data, a spike in CPU from one service, an error log from another, and a corresponding slowdown in a user transaction trace, to rapidly pinpoint the exact source of a problem, significantly reducing mean time to resolution. Thirdly, reduced alert fatigue. Instead of a deluge of generic alerts, AI intelligently prioritizes critical issues, filtering out noise and presenting actionable insights. Finally, performance optimization. By analyzing patterns and dependencies, AI can uncover hidden inefficiencies, guide resource allocation, and recommend optimizations that directly improve your application's response times and resource consumption. This isn't just about finding problems, it's about making your Java apps perform better, smarter. At the heart of any robust observability strategy, and indeed, what fuels these AI tools, are three fundamental pillars: metrics, traces, and logs. Metrics are numerical values collected over time, representing the health and performance of your system. Think of them as vital signs: CPU usage, memory consumption, request rates, error counts, database query times. These aggregated values provide a high-level overview. Next, traces offer an end-to-end view of a single request as it flows through multiple services in a distributed system. A trace visually depicts the path, showing latency at each hop and identifying dependencies. Lastly, logs are discrete event records generated by your application code. They provide granular details about specific occurrences, critical for debugging and understanding the context of an issue. When an error happens, the log provides the stack trace and relevant messages. AI-powered tools ingest and process all three of these data types, correlating them to build a comprehensive, intelligent understanding of your application's behavior. So, how do these powerful AI-driven observability platforms like Dynatrace and New Relic actually see into your Java applications? The common and most effective method is through a Java agent. Think of a Java agent as a specialized, lightweight JR file that you attach to your Java virtual machine, or JVM, at startup. This agent doesn't require you to modify your application's source code. Instead, it performs what's called bytecode instrumentation at runtime. As your Java application loads its classes, the agent dynamically modifies the bytecode, injecting its own monitoring code. This allows it to automatically collect critical telemetry data, your metrics, traces, and logs, with minimal overhead. Once collected, this rich data is then securely transmitted to the respective monitoring platform, whether it's Dynatrace One Agent or New Relic's Java agent, for deep analysis, visualization, and, crucially, AI-driven anomaly detection. It's a seamless, non-intrusive way to gain unparalleled visibility. Before we dive into the practical setup, let's ensure you have everything in place to follow along. To build and run our demo Java application, you'll need the Java Development Kit, JDK, version 17 or newer installed on your system. We'll be using Maven for building our Spring Boot project, so make sure that's also configured. If you plan to experiment with containerization, Docker will be essential. Most importantly, you'll need access to a Dynatrace environment, SaaS or managed, or a New Relic account. Both platforms offer free trials, making it easy to get started. Finally, you'll need to download their respective Java agents. For Dynatrace, it's the oneagent.jar file, typically found in your Dynatrace environment's deployment section. For New Relic, you'll need newrelic.jar and its configuration file, newrelic.yml, both available from your New Relic account's agent download page. Having these ready will ensure a smooth demonstration. Our demo application is a simple Spring Boot service designed to showcase various behaviors that generate useful telemetry data. It's a standard Maven project, and building it is straightforward. Navigate to the project's root directory, which you can find in the provided code repository, and execute the familiar command, mvn clean install. This command will compile the Java source code, run any tests, and package your application into an executable JAR file, typically found in the target directory. This JAR is what we'll be running and instrumenting. Our application includes a demo controller.java with a few endpoints, a basic hello endpoint, one to simulate CPU load, another to simulate errors, and even one to introduce artificial delays. These endpoints are crucial for generating diverse data patterns that our AI monitoring tools can then analyze and learn from. Now, let's get our Java application sending data to Dynatrace. The core mechanism is attaching the Dynatrace One Agent to your JVM at startup. This is done using the standard Java Agent JVM argument. You'll specify the path to your downloaded oneagent.jar file. Beyond that, the Dynatrace agent requires a few environment variables to know where to send its data and how to authenticate. Key variables typically include DT_tenant, your Dynatrace environment ID, DT_tenantican, a security token, and DT_connection_point, the URL for the agent to connect to. You'll find these specific values within your Dynatrace SaaS or managed environments, Deploy Dynatrace Install OneAgent Java section. Once these variables are set and the agent path is correct, your application will automatically start sending metrics, traces, and logs to Dynatrace, where their powerful AI engine will begin processing and identifying anomalies. Similarly, integrating with New Relic follows a very similar pattern. You'll attach the New Relic Java agent to your JVM using the Java agent argument, pointing to your newrelic.jar file. New Relic also relies on configuration to connect to your account. This is typically managed via the newrelic.yml configuration file, which you'll place alongside the agent JR. Within newrelic.yml, you'll set your license_key, obtained from your New Relic account settings, and ideally an app_name to easily identify your application in the New Relic UI. Alternatively, you can override these settings using environment variables like new_relic_license_key and new_relic_app_name. Once the agent is attached and configured, it will automatically instrument your Java application, collect telemetry data, and send it to the new Relic platform for analysis.